Here in example 1, we are taking the curve y equal x squared from the point 0, 0 to the point 2, 4. We are rotating around the x-axis here, and we want to set up the surface area integrals with respect to x and then also with respect to y. And then here are the formulas. So this first one is with respect to x. Remember that this piece right here is our arc area element, ds. And then this is with respect to y. Y is the same as f of x. And then this piece again is our arc area element ds. So let's sketch a picture, get an idea of what this surface looks like. So y equal x squared, our parabola here. And we're going from the point 0, 0 to the point 2, 4. We are revolving around the x-axis, so this piece here is going to get revolved around the axis. We'll have something that looks like this. So we get this kind of caved-in funnel that's turned on its side. That's what we're going to find the surface area of. So part A here, we're going to do our area with respect to x first. So we're going to integrate with respect to x. So our x coordinate goes from 0 to 2. So this will be an integral from 0 to 2 pi. And then our function f of x is x squared. And then square root 1 plus, and then our f prime of x, derivative of x squared is 2x, so that's going to be 2x, quantity squared dx. So there's our x integral. And now let's look at our y integral. So we are going to integrate y coordinates here. A and b are going to be y coordinates. So we're going to integrate from 0 to 4 in y. And then 2 pi y. And then we got a square root here, and we're integrating 1 plus f prime of y squared. So we have to solve this equation for x to get our f of y. So if y is equal to x squared, and we take square roots on both sides, then our x is going to equal square root of y. The positive square root of y is going to be this piece here and the negative square root there. So that's y to the 1/2 power. And so this will be 1 plus, and then our f prime of y, so our x prime here, 1/2 is going to come down times y, decrease our exponent by 1, so 1/2 minus 1, negative 1/2. And that is the same as 1 over 2, and then y to the 1/2 in the denominator is square root of y, so 1 over 2 root y. So that is our f prime of y, and that guy gets squared, dy. So here we could we're set up. This is done. Let's simplify a little bit and see which integral might be easier. So the 2 pi can come outside here. We're integrating 0 to 2. We've got an x squared and then square root. This would be 1 plus 2x times 2x would be 4x squared dx. So that is looking like that might be a trig substitution or possibly a rationalizing substitution. And then for the other integral here, we're going to factor out that 2 pi, integral 0 to 4, and then square root, well, we got a y left in there, and then square root, this will be 1 plus 2 root y times 2 root y would be 4y. So it would be 1 over 4y dy. And let's see here. So we would get a common denominator between these. We'd have 4y plus 1 over 4y. not quite sure what would be the best way to do that one. So, if we took this one step farther, I think the x integral is definitely the easier one, even though it's a trig sub. So this would be 0 to 4, y, and then we've got square root. Write the 1 as 4y over 4y. So 4y plus 1 over 4y dy. And then we could take square root of 4 is 2, square root of y is root y, and that root y could cancel in here and leave a square root of y there, which could multiply in. I'm not sure. Let's take this one step farther here. So this one looks like it's a trig sub, or possibly a rationalizing substitution. So two things to try there. For this one, we can do, we got our 2 pi, integral 0 to 4, y, and then root 4y plus 1 on top. Square root of 4y on the bottom. Square root of 4 is 2, and then we have to leave the root y. So this 2 could cancel here, and the root y could cancel into y and leave a square root of y, which would give us pi on the outside, integral 0 to 4, and then root y times root 4y, we can multiply those underneath the root, 4y plus 1. So y times 4y be 4y squared, plus, and then y times 1 is y dy. So that simplifies it, but I think this is going to be completing the square plus a trig sub. But that's definitely going to be tougher. So complete the square to get a perfect square in there, and then plus a trig sub. But definitely this one, even though it involves either trig or rationalizing sub, is going to be the easier integral to attack.